Thanks for that email earlier today as well, John.
Yeah, I thought I'd better remind you because it's one of them. Obviously, people who don't know David Ellis is one of the MERG leaders within the Merseyside area group with myself. So we've been demonstrating, or I've been demonstrating LCC DIY projects in that. Uh, and obviously, that is sort of growing as we try and show more people what we can do. Uh, but I've been sort of struggling for the last couple of months with getting the house, big jobs done in the house, bad back, and working on the layout. So uh, it's been one of them. Things are taking a little bit longer than I thought they would take because I never planned the layout. I just built it, threw it together, added more stuff, and then wondered why, you know, now I want to change it. It's a case of sort of doing the rewiring of the DCC on it. It's not a big layout, but I thought may as well do it now and get on with it. I'll just give it a few more minutes in case there's late stragglers, because I know we've got two meetings taking place tonight within MERG, so whether people click on the wrong ones or not, I don't know.
What's the other one, John?
Tayside area groups having a Zoom meeting tonight.
Right.
That's one of the problems trying to work the dates out. Uh, I know Ben was joining us tonight as well. He's from France. Now, whether I say he's joined the group again, so he's got the link to the email, but he actually has had it from me already. So, uh, obviously, David Harris, I'll just bring you in a sec.
Oh, yes.
All right, David. For those who don't know, David is the other leader of this group. Really, David's the brains behind the group. I'm mainly the facilitator and sort of pull the meetings together and do the videos and sort of I play with some ideas for code. So, how's things going at your end, David?
Oh, pretty good. I sent you a new update. Got rid of A, B, C, D.
All right. For those who don't know, obviously, I because of what I'm doing on my layout, it's all going to be, I call it the Arduino ecosystem version of it, even though I'm playing with the SP32s at the moment, which sometimes throw up some strange things for me. So we've just been testing out one of the next, for my Mimic panel, I want to get some more MCP 23017s on the ESP32. So we David has just been having a rework of his library because obviously all the things that I show are based on David's library, which is originally Bob Jacobson, is it, and Alex Shepherd and a few of the others. I don't know whether Alex is going to be joining us tonight. Sometimes he does. Just bear with me a second. I'll have a
I've been talking to David as well along similar lines to you, John, just the last few days. So I was hoping I'd be able to, get a little bit of fiddling about done, but just timing. I mean, I've had one of those days where I've gone through, I think, about 6 nested interrupts today with emails coming in faster than I can deal with them, and I still haven't got back to what I was trying to do this morning.
So, David, I've been working on your program with the PCAs.
Oh, great. Okay. Yes, John sent me an email this morning pointing out that somebody else is also working on commercial PCA applications there as well. So that's quite
yeah.
interesting to see. Always encouraging because it sort of looks as though everybody's sort of converging on similar ideas, which is useful.
Yeah,
Yeah.
that came up from Snowball Creek. Uh,
Uh,
he's put up. I'll show it shortly. He's shown us some boards that obviously he's designed and looks like they're going to be shown at some event. And I noticed he's got a PC 9685 on one of them, which I thought, right, okay, that looks good. So it's nice to see sort of some of these other things. But what I'll do with, obviously, I'm going to bring on Bob McCown. Obviously, I put a thing out on MRH to say, obviously, the group's having a meeting, and that sort of helps the advertisement. And then also with on Group IO. Now, obviously, there's two Group IOs, which threw me a little bit. One's for the Open LCB group, and one is for
That's more development.
yeah, and the MNRN is it Open LCC, sorry. So reached out and Bob came and said he'd be happy to give us a talk on the projects he's been working on. So are you ready, Bob?
I am. Yep. Yeah. So thanks for inviting me. Maybe I should give you like my 30-second elevator speech. I've been playing with OpenLCB, I don't know, for a long time. I have some of Tim Hatch's original boards when he had those. And I've been sort of in the outskirts of this for a while, playing with my own designs and stuff. Within the last year, I've retired. So that's let me actually spend more time on things. And at about that time, Dave Harris, I ran into his single thread library. And around the same time, I started playing with the ESP32s. He has a nice little Wi-Fi library in there. I added a couple of patches locally to make it a little more robust. I've sent those to him. But I come at it from a hobbyist standpoint of the, why would I go off and buy a board when I can spend twice as much money and do it myself? So that's where I am here. I also have a garden railroad, so I have things to worry about like weather and wires and animals and everything else. So doing the Wi-Fi nodes works better outside for me because I don't have hundreds of feet of wire underground where squirrels and everything else is going to eat it. So that's where I am. Within the last year, I've pestered Dave a little bit and shown off what I've done. I've got two projects that I've been working on. One is 99% done. I've been playing with it in about an 8 or 9 node configuration. And that one is this little board here. All my boards are very simple. They're just I/O with a little software behind it. But this is a board designed to sit at a switch, at a control point. And I've designed this for myself. It's got enough I/O on this side, or it's got outputs on that side that'll drive 4 3-color signal heads. On this side, it's got inputs for up to 4 block detections. And then I have 4 auxiliary inputs and 4 auxiliary outputs for other things. Like maybe I want a maintenance light on the shed or something, or I want to see which position the switch is in. It'll send it that. These are all on ESP32 hobby boards. I've used MCP 23017s to get more I/O. These are cool little, I love these things. I can change the address of the node within my subnet. I can change the last 2 digits of that using these dip switches here. So this allows me, if I have a board go bad outside, I can just swap this one in, change the address, and it just picks up where the other one left off. So that's kind of my philosophy on how I design these things. I also, this little jumper here, I can set it so that I either have common anode or common cathode LEDs. Mostly because I have common ground on a lot of my stuff, but the 3-color LEDs that I found only have common the other way around. So I made a modification to the board to add that. All of this stuff I drive by JMRI. Since I just got this board working in the last few months, I've just started doing the JMRI programming on this. They work very well. At least for I've had them running for, a couple of days, simulating traffic. I modified the software I put on these things to simulate traffic and change signal heads and do detection. And they seem to stay stable. So I think they're probably perfectly fine for, nobody runs the stuff for days and days. I can give you a quick little demo of this. I got to change my cameras here. Hang on. If I go to that one. So I've got my board here. this is one of my little test harnesses when I assemble one of these to make sure all the I/O is working. And this is just a switch. So I can go into JMRI, the signal mass table, and so I have this set as 1 2-head signal and 2 single heads. So that would be the approach and the 2 switches, or the 2 tracks going into one. So I can set one of them to clear, and oh, look, it goes to clear. I can do advanced approach. It immediately goes, it blinks at the rate I would expect. There's no delays or anything. I can change that to the other signal, to the 2-head, to the stop, or that one to diverging advanced approach. So they all work and they all respond how I would expect to work, and they work, quick. There doesn't seem to be a delay. The range on these is pretty neat. Some of you, if you were on the Open LCB list, I had one that has I've got the option to put a little OLED display on this. And what I did is I just had it saying, what's the dB? And I walked around my layout outside. And I went to the farthest point of my layout, and I still had good connectivity. Nothing dropped out. So I think these, as long as you've got a good Wi-Fi, these connect to my home Wi-Fi. They work pretty well.
Bob?
Yep.
Who's doing the blinking on that? Is that JMRI blinking?
That's JMRI. So so the advanced approach does the blink on the LEDs.
Yeah.
And that was the one that I was worried about, that there was going to be
Right.
too much traffic or things were going to get dropped or whatever.
Right.
And no, it just does the blinking. I go over to the signal masthead. I say, I want this one to be advanced approach. And oh, look, it's blinking. And it's blinking with no delay. It's the cadence I would expect. It doesn't drop a blink. It doesn't stay on for more than a couple seconds or off. It blinks at the rate I would expect it. That's that one. And the other project I've been working on, that just half an hour ago, the board showed up. So I haven't assembled one, but I kind of threw some of the hardware in it, is the same thing. It's a Wi-Fi based, so it doesn't have the CAN bus in it. And oops, let me change my camera back so I can show this one off. And I go to here. Is this little bad boy, which is the same thing. It's a Wi-Fi based that uses the XIAO ESP32C6 processor, which is a little tiny one. And this is made to fit in a standard USS CTC panel that has all the controls in it. Again, it's a fairly dumb board. I still haven't fleshed out the software yet. I'm hoping this board is correct. Like I said, I haven't assembled one. But this is just enough I/O for one of those columns in the board. All the same things. You can change the address on it. It has the I/O for the lights and everything else. A bunch of auxiliary stuff so that it can have on the model board up above it, you can have all the little LEDs or any other push buttons that you want. That's where I am.
So how many nodes do you think you'll be able to use within JMRI and the Wi-Fi?
I'm not sure. Like I said, I've got, what do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 11 of them assembled that I've had running together over the Wi-Fi, and they seem to work okay. So I'm not sure. I haven't seen any drop stuff. I don't have any packet analyzers or anything that I can run on the Wi-Fi to see what's going on, but I haven't seen, at the rate that, at least just for signaling and detection, I don't think there's enough traffic even over Wi-Fi to cause that much problems. It's very, oh, I've entered a block, and then 4 or 5 seconds later, oh, I've left the block. There's not a whole mountain of traffic coming in like there would be for, other things like the throttles or anything like that. So for signaling, they seem to work pretty well. All of my designs I'm putting up on GitLab, the Eagle file. So if you wanted to burn your own boards, you could. I'm not a manufacturer. I don't want to get into that end of it.
I know for the MERG, people on MERG, I've actually put a link to your GitLab. And obviously, when I put the video, I will put that in the description of it. I see, Balazs, you put a question in the chat.
Yeah, my question was, do you plan to connect the CTCs wired or wireless?
These are the ones are wireless. I will probably have some wired stuff as well, simply because there's a lot of lights, and I can use some of Tim Hatch's boards that I have to drive those. So all the other lights that aren't driven by my little board here will probably be via the CAN bus, just wired lights, because that's just going to be sitting in my shop basically in its little CTC room.
Bob?
Yep.
Can I just ask you about, I love the idea of using the dip switches to set the last section of the address. That's a very neat idea. But doesn't that rather, isn't it counteracted by the fact that you've still presumably got to set all the parameters in the CDI?
Well, the CDI doesn't have, well, using the way the library is set up, I hadn't had to make any changes to the CDI in order to have the IDs correctly show up in JMRI. Now,
Yeah.
whether there's other things in the spec that I'm not aware about,
No,
that's
no,
entirely possible.
all I'm meaning is surely that means that every module has to be absolutely identical. You can't have some controlling, a few digital in out here and a few servos there or whatever. And normally, for us on our baseboards, we might have, 3 servos on one board and 1 servo on another and 3 digital outputs on one and 5 digital inputs on another. They'll be all different. And I'm thinking that if you've got to go in and reconfigure the unit anyway with the CDI info to, and restore it, is there that much advantage in having the dip switches, or is it just as easy to just do that as part of the CDI function when you're actually doing that bit of it, if you see what I mean?
I mean, I suppose I could, but like I said, the way I've built these is this is for a very specific kind of thing. It's for driving 4 signal heads, and it's for to have up to 4 inputs. Now, if you're not using the inputs, for example, in JMRI, you wouldn't have to say, oh, I have these 4 auxiliary inputs. They would just never show up there. Those 4 little bits of address space would never run across the network, but they are there if you want to use them. I could also do this. You could set this up to only have 2 color signal heads in JMRI. There's one of the signal logics that you can say, oh, I have red and green. This will work perfectly fine. It just you just wouldn't set the yellow. You would set the red and the green. You would point your signal heads, and the way the tables are all set up in JMRI, they just seems to work.
In effect, your CDI is identical for all of the modules. Is the issue there, isn't it?
Exactly. Yeah. These are a very specific thing. It's just this many input, this many output, whether you use them or not.
Yeah. Fine.
Yeah, they're simple inputs and outputs.
I mean, the only thing I might do on the one for the CTC is not send any events until the code button is pressed. That seems to be more like what would happen, as opposed to having to add a bunch of scripting to JMRI, say, hey, this event happened, but he hasn't pressed the code button yet. So save this state off just in case he might change it. But wait a minute, he changed it back. He changed his mind. So I think that's where my brain is leaning to as I've been playing with the software, waiting for these boards to show up.
I must admit, I had to watch a video on the CTC boards, and I noticed on that you could change the turnout position, but nothing would happen until that button was pressed. And I thought, oh, that's neat. Because I've never looked at how it's done in America or how we do it here. I've got in my mind what I want to do. But I just say, then you've got to put the logic within the actual module is my way of thinking at the moment. Because I didn't realize you could do all them delays within JMRI. So again, that's the nice bit with seeing how other people are approaching it.
Right. I mean, I think the idea is when you change the settings on the column, the operator is going, okay, is that actually correct before I make that switch throw and I put the signal in that way? Is like, even though the interlocking is going to prevent anything stupid from happening, there are also delays. It's like, they don't switch a switch and then switch it immediately back. So that's from my understanding is they give you sort of we're not going to do this until you tell us that you want us to try to do this.
Yeah. That's a neat thing. As I say, that's the first time, and I've seen in JMRI you've got the lights of that panel behind you. You can create all that, but I didn't, in my brain, didn't quite know, well, where would I use that? But it's certainly an interesting thing. I see, David, you've just put garden layout. Yeah, as you say, the traffic being quite low.
Right. I mean,
Wi-Fi.
when I have operating sessions here, I have basically two train, or I run I can run up to 5 trains at once, 2 in each direction, and then 1 on a branch line. And the branch line will be dark territory. The switch going down to it won't be, but that will be dark. So like David said, the traffic is very low. Right now we run without any signals or operators or anything, just sort of, rock, paper, scissors, who's going first and am I going to be in your way? So
Are you able to display the JMRI and the CDI within there, or is that possible for you to share that so people can see? Because that's what I like with, I say, I'm working with David at the moment with a lot of the stuff I'm doing, and having that CDI is so nice to be able to do what we want it to do.
yeah, so let me share my screen and pull up the configuration dialog here for this. Refresh that. No, it's dropped off. Oh, here it is. All right. I lost Zoom. There's Zoom.
The joys of Zoom, sometimes screens don't always want to play.
Yeah.
It's starting to come through now, Bob, so yeah, okay.
Yep.
So this is the node, it's got all the blocks and then all the signal heads down here. Basically just like any of the other ones that I've played with.
So is the interlocking all being controlled through JMRI, or is that controlled through the actual node?
No, it's all, these are just dumb IO nodes. There's really no logic beside. So it's all just JMRI stuff. As I get more experience with the LCC, Open LCB stuff, I will probably add smarts to it.
I think Balazs, you put your hand up.
You got a question?
Yeah. My question is, how do you connect through the Wi-Fi to JMRI? Like, are you running the JMRI hub? And
I'm running the JMRI hub, and Dave Harris's library has a Wi-Fi grid connect module in it that I'm using. I basically started at his example and worked my way out from there.
Did you have to configure the IP address of JMRI, or are you?
You do. So when one of these nodes first starts up, it doesn't know the Wi-Fi, so it spins up its own access point, just like a lot of these devices for home automation and stuff. They spin up an access point and you connect to it and tell it what your network is. This does exactly the same thing.
And does it use MDNS to find JMRI?
I'm not sure the inner workings of the way the library works. So
yes, it does.
Okay.
And then I've even on the board that little button right there in between the two chips does the Wi-Fi reset, just in case you're change your home network to whatever. You can just hit that, it clears it off, and the next time you'd go in and connect to it and change whatever network you're on.
All right. So you said that you tried this with up to 10 modules and it seems to work fine, and that's great. if you want to actually like stress test it, you should see what happens if there is a large amount of traffic elsewhere. So connect all of your 10 modules and make it blink. And then, I don't know, start a firmware upgrade, for example, over the CAN bus from JMRI, and then you will see how do your modules react to having a lot of traffic on the bus.
Hmm.
Because that's usually how you can kill modules, by sending a lot of unrelated traffic to them.
Okay, I'll give that a shot.
So how many of you actually got connected to JMRI at the moment, Bob?
Right now, I just have the one because
Just the one. Okay.
I didn't want anything else to happen while I was presenting. But you know, I can, if I were to plug them all in, they would start showing up. You know, it takes about 40 seconds for one to show up.
Yeah, I did have a go with David. I think you did an example, didn't you? I think, was it a Pi Pico one or not? I can't remember off the top of my head. And I did try that, and yeah, it did take a few, well, about 20, 40, 50, 60 seconds for it to actually show up. But that was only just so I could say, yeah, okay, these were the things when I was trying the different example sketches. So it's good to see somebody else who's working with the library.
Yeah, and a lot of that seems to be on initial startup even. It's not, when I look at the, I use the Arduino IDE. When I look at the serial monitor, it spools up and then it comes up and it says, you know, searching for the LCB hub. And that seems to take 10 or 15 seconds, even though it's right here. It's still, that seems to, I don't know what the cadence of that is, but it seems to take a little while. But it's still pretty neat. It's still pretty good. I mean, if you're gonna start your layup up, you know, everybody always turns everything on hours beforehand, anyways, to make sure everything's okay. So.
Yeah, because one of the things I've noticed, obviously my layout is going to use JMRI all the time. So, you know, that, but what I've found is I have to start JMRI up first and then put the power to all the Arduinos or the ESP32s around, so that gets to know all the states. But at the moment, I've ripped a lot of them out so I can restart again, make sure everything's neat, tidy, following best practices as best as I can for wiring.
Yep.
Obviously, I've been playing with the Arduino Nano, but again, that one, it is using the MCP2515, which I know is not the best CAN module, but again, the layout's not going to get that much traffic, so I want to try that to see how it plays. But obviously now I'm working with the SP32s as well. But I say it's just some of the little quirks I'm finding with the SP32 that sort of baffles me a little bit.
Yeah, I found ESP32 development board that has the CAN on board, but it was the same thing. It was a 2515. It was made for people that are hacking at the automotive CAN bus, and it already has all the chips and it's got the plugs on it. I was going to order one of those out and see how it is.
This is the one I'm playing with at the moment. That's the Dev 1 board.
Yeah.
And then I'm using the small transceiver here.
Okay.
Obviously, at the moment, I'm using Grid Connect just because I thought I can demonstrate it. This has only got the one MCP, which is not actually plugged into it at the moment. So we're working at the moment to try and get the second MCP up and running. Once that, well, David's just sent me a new bit of code, which I've got this set up now with two, just so I can show what we're looking at. But it's nice to see. I think we've just had an issue with the EEPROM, I think it was. Was it, David? And I've just changed that in the library, in your main library code. So that fixed that, and then it threw that other little error. So we're sort of finding things and then fixing them as we develop it. But that will give me, at the moment, with 2 MCPs, it'll give me, with 8 native pins on the ESP32 and 32 on the MCPs, gives a total of 40 IOs. So in theory, because of the mimic panel I'm building, in theory, I'm going to need a lot of outputs. Now, the MCP 23017, 2 of the pins on that, on the module I've got, can only be outputs. They can't be inputs. So that caught me out. So I had to quickly change the documentation I'd been putting out on GitHub, because the one I was testing is an old version, and that would allow all 14. Sorry, all 16. The new one has caught us out a little bit.
Oh,
Yeah.
I didn't realize it was the new ones that were bad.
Yeah,
That's interesting.
Yeah, the new one's the one they changed it for some reason. And I say, for when I was testing, I didn't know about it, and then it cropped up. Davy Dick, who's a MERG member, does a lot with Arduinos and all sorts else. He'd come across it, and obviously he made us all aware of it. The
Yeah,
next
David,
thing,
you told me about that too. When I was in my board design, you're like, by the way, did you know pin 7 on both A and B? I'm like, oh, no, I didn't. Thank you.
yeah, and that's the nice thing. The thing is, if when you know about it, the fact that it's all DIY stuff, we can change it. Obviously, I'm approaching it slightly different, Bob. I haven't got the time or the skills to design PCBs, but I'm trying to go from a modular approach, very much like the guys at DCCX, where they went modular. So hopefully more what I would call tinkerers would be prepared to have a go at what we can do with LCC. Obviously, we've got a number of commercial products available. I did have a play with the OpenMRN library while I was away last time, and there's a few little gotchas I didn't quite know, and I got it home, I got it to work with connecting with Balazs, but at the time I wasn't able to then sort of carry on demonstrating it. So I did reach out to Balazs to see if that could be demonstrated at some point, just to make sure we're saying the right things about that library and the way we use it. Because obviously I know how we're doing it with David's library. I'll just show you if I can. Hopefully, so this is the node that we're working on at the moment. So obviously, this is all loosely based around the very first sketch David did for me, which was a 2 servo 8IO for the Arduino Nano. So I've stuck with that, and we've been developing a number of other variants for different modules, and obviously David's been doing it for different processors. So on this one, we can control the speed of the servo. Unfortunately, it's 2 servos on an ESP32 on the native pins, but you can only set the speed for one. And we could move this down below. So then we've got the servos. So at the moment, we've gone with 3 positions: closed, mid, and thrown.
I'm not seeing your screen
Hold
properly.
on a sec. If I share this one, then maybe. Okay, sorry. So you're seeing this
Oh, that's it. Yeah.
CDI? Sorry,
There we go.
I picked the wrong screen. So I say this is all based around the original sketch we had. So we got the speeds. Here we can save to the EEPROM the position. These are the 3 positions we've got available to us. I just went with what JMRI called them, which is closed and thrown. Obviously, you've got normal and reverse, and there's so many different ways. Obviously, that would have to be changed, hard coded. Then, obviously, we can set the positions of it. Then I say this hasn't got the new software on it yet that David's just sent to me now. So here we've got the 8 native pins, and then we can set them between inputs inverted, outputs and pull-up, outputs and inverted and PBs. So these are what I've been demonstrated when we did the level crossing sketch or the level crossing use of it. And then we've just added, I actually showed a 24 version of this. So we've just now got the extra ports on it. But at the moment, the one I've got running on it, it's got this with slight bug because it's throwing the in. But that's the one I'm working on at the moment for my Mimic panel. In theory, there'd be nothing to stop me if I wanted, because I suppose I could put an extra 23017 in, keep them close together, so it's never going to be more than 6 inches away from the main MCU. So I'm not too worried about the I2C detrimentation of it, where you're breaking up. But this is quite a nice module. I'll stop sharing there. So the things we're developing, obviously with this one, you've only got the 2 on and off events, haven't you? Some of the other modules we've been working on, we use the term actions, I think it is, David, where
Right.
we can do a lot more with those. I did do an Arduino Mega with David, which would give me 64 IOs, I think it was. But that one, we've got, I think it was about 140 actions, so each pin could have multiple actions. So you could have it flashing an LED, or another event would make it go off and on. And so that's where that one was. I just need to get that connected up against the CAN bus. So there's lots of different options that we're able to do through the OpenLCB single thread library. But that's the thing. Has anybody any questions for Bob on the Wi-Fi? Because I know I've sort of drifted off a little bit there. Because I know John Callingham, he was going along the lines with the Wi-Fi as well for his home layout. John's not on the call. Unfortunately, Wednesday's probably not a good night for most MERG members by the look of it. There's a lot of people go to clubs and different things like that, so it's a bit hit and miss with the people. Yeah, John did some time of flight sensors. So I'm not sure how he's getting on with, or how far he's taken that. The other member who's been working on stuff is Benoit in France. Do you want to give us an update, Benoit?
Yes, thank you, John. Just give me 1 second so I can access to the presentation that I have prepared. Give me 1 second, please. Because of course I closed the window where the presentation was. 1 second. So while it's loading, so yeah, very quickly, what I did, the work I started to do. I'm quite, I would say, quite a beginner in OpenLCB. I was looking at it since a long time, but I never really started to work on that. And I started to take a deep look a few months ago. Then I asked to some members of these SIG to get some help. And finally, I wanted to understand how this thing was working, how OpenLCB was working. I wanted to write something from scratch, so I didn't want to rely on an existing library. Not because I didn't want to, not because I didn't trust them or something like that. But I preferred to dig really in the code and understand how the thing was working. Honestly, there is one thing I want to share with you. You have to know that in France, we have a forum called Low-Code We Know. So as the name says, it's how to make trains, model trains running with Arduinos. And there are a lot of, I will not say a lot, but there are some discussions on this forum. For those who can read French, it's pretty strange to read that the feeling that the guys on Low-Code We Know have is that OpenLCB is a complete mess, and it's that's exactly what they write on that's exactly what they write on the forum. They say, oh, it's very difficult to understand. There is a lot of documentation, and it's really a mess. That's the term they use. So I was wondering if it was really interesting to take a look. But finally, I have to say that it's not so complex. It's just that everything that you find on lcb.org website, it's specification, and the specification are not made to be, I would say, easily. It's not something that you can read easily because it's not the goal of this document. I understood that, in fact, these documents are written in the way that the answer to any question that the programmers can have. So it's not something that you have to read to understand how OpenLCB and how LCC is working. And thanks to the help I got from some people from this group, I understood where I had to look first. And as I said, my idea was to write something from scratch and to make something I would call useful. So what I have done, hold on, I'm trying to share my screen. Every time I look, where is screen sharing? Where is it? Where is the button? Sorry. Here we are. So, yeah. Okay. Can you see my screen?
Yes.
Yes.
Okay. So, first of all, in the Raspberry Pi group, last year I made a presentation about a library called CAN 2040. It was not written by me. It's a very interesting library, which was written by, which is available on GitHub, so everybody can access to it. And it's very interesting because it implements CAN. So basically, you can use it for CBUS and for OpenLCB. The thing is that it does not use an external CAN controller. So it uses only the PIO located on the chip to, I would say, manage the CAN communication on the RP2040 and on the RP2350. So because the library runs on the two chips. And the thing is that at this moment, it only takes two IO pins to communicate. So it's for CAN RX and CAN TX. And all the GPIOs are available, including the SPI. So basically, it does not use at all the SPI. So and you don't need to use a chip like an MCP 2550 or something like that. So what I just said is written here. So that's where you can find the source code of CAN 2040. I wanted to make this slide because there is one thing when you deal with CAN 2040 is that you must compile the code using the release mode. Because otherwise, what happens is that the chip sometimes lose a few messages and it's written on Kevin O'Connor's website that you must absolutely compile everything in the release mode. So what I've done, to be simple, what I do is that I compile in release mode the code. So I use the original C++ SDK from Raspberry Foundation, and so I use VS Code to compile the code. I do not use Arduino IDE. And the second thing, what I do is that I run on the second core. So I reserve, if I can say that, the second core of the chip to run the CAN stack. So at this moment, it works perfectly well, even if you put the bus, so it's not the case of OpenLCB, but even if you put the bus at the full speed, which is 1 megabit per second. So at this moment, it's very, very reliable. It works perfectly well. I made a lot of tests with the bus loaded at maximum, and that the chip does not lose any packet. The only thing that is known, but it's really nothing, is that the error modes, which is in CAN specification, you have a dedicated part which explains what the chip shall do, what the CAN controller shall do in case of communication error, etc., etc. You have it's a quite complex document, and the thing is that this library is not perfectly following the CAN specification, but honestly, it has absolutely no impact. It's only to this part of the CAN specification only explains what the chip is supposed to do, what the CAN controller is supposed to do. When there are a lot of error, when you have a burst of errors and things like that. So as long as the your bus is stable, is working well. Finally, the fact that the library is not perfectly compliant with the CAN error management it has absolutely no effect. So what I did is
I have a question.
Yep.
If you have a moment, does it do the CRC checking?
Yeah, of course. Yeah.
And does it reject the frame with an error frame if the CRC is wrong?
Yeah, exactly. So it's absolutely compliant with first the CRC. So if you have, first, if you have a CRC error, the frame is rejected. The ACK bit is not generated. So at this moment, the packets are automatically repeated.
No,
And
that's not going to be the case. That's not going to be the case. Because another component on the bus is going to generate the ACK. You actually have to actively create the error frame in order to enforce the retransmission.
Yeah, but I mean, if you look at the MCP2515, for example, you can choose if the chip repeats the packet if the ACK bit is missing, or if it just sends. I don't remember how microchip is calling the mode. It's one-shot mode. So you have even access to this in the CAN.
That's not the situation I'm talking about. If you have more than 2 devices on the bus, one of them is sending. The second gets a CRC error. A third one might produce the ACK bit. And in this situation, the first one is going to say like, okay, this message is sent all fine. Then the second one actually did not receive it. The message disappeared for the second one because it got a CRC error. This is why the CAN standard actually requires actively creating an error frame if your CRC is wrong. Not just missing the ACK, but actively creating an error frame.
Yeah, but this is, oh, sorry, I got it for the behavior you were reflecting. Now, when I was talking about the error modes, it's when you have, I don't remember exactly the name within the CAN specification, it's when you have the error counter. So when you reach a given number of errors.
There is error passive mode, error active mode.
That's it, that's exactly. Yes. So that's where there is a difference. The chip does not go exactly in the same conditions in error active or error passive, but it's only where there is a difference. But for the rest, it's absolutely compliant. And it even implements the automatic arbitration. So when So this is really the part of CAN. That's where CAN is very interesting, because if you have two nodes who are transmitting at the same time, then the node running CAN 2040 is able to say, oh, okay, somebody has a higher priority than me, and it stops transmitting at this moment. So what I have here, I have a setup made with.
Sorry, I have more questions.
Yep.
Do you actually set the bit timing parameters for this library?
Alors, not exactly in the same way as you do. Yeah, that's where there is, I would say, quite a big difference. When you take a look to the classical, if I can say that, CAN adapters, you have a segment times, and you can define precisely the different position with sampling time, etc., etc. It doesn't work like that in CAN 2040. What you do, you just give the core frequency. So theoretically, it's 125 megahertz, and you give expected bit rates. So, for example, for OpenLCB, it's 125 kilobits per second, and it uses basically, I don't remember where it took the values, but the guy who wrote the library used the table with recommended parameters. So you cannot adjust by yourself the different segments. It uses the recommended segments value for the sampling and things like that. But the way you set up the bit timing is not the same.
But does it correctly implement the synchronization jump?
As far as I know, yes.
Because the problem is, if you are not in control of the bit timing, then you don't have the ability to set the bit timing in a way that you will be compliant with the maximum bus length, the maximum cable length requirements for OpenLCB, at the same time as complying with the requirements of frequency tolerance. Because there is a frequency tolerance that is subject to your device and then the other device that is talking on the bus.
Mm-hmm.
And the frequency tolerances of these devices and the cable length that's in between them, they are actually interacting with each other. They're interacting with each other in a way that the error-free communication is only guaranteed if the bit sample settings are correctly set up. Otherwise, you will not work over very long cables, or it will not work with devices that don't have crystals. And for example, like the railroad circuits boards, they don't have crystals. So it is possible that over a longer many meters of cable, you will not be able to communicate with like a railroad circuits device.
Yeah, that's true. The thing is that, once again, I'm not the author of the library, so I cannot tell exactly how it chose the different values. But yeah, it's pretty sure that for extreme case, like very long cables and things like that, there may be problems with the library. Honestly, here on my setup, I have, so my complete setup is mixing PIC microcontrollers, MCP 2515, the CAN 2040 running on Pico, and I never got any problem. I made a lot of tests with burst on the network and see what happened. I never lost any message. To be honest, I had during a time more problems with the kit 86 running on Raspberry Pi with the old driver, the previous driver, which was implemented in the kernel. But it was just because the Raspberry Pi is not fast enough to handle all interrupts coming from the MCP 2515, sorry. So when I was losing message first during my first test, it was not because of the I would say the software library. It was just because of other systems which were not able to deal with the amount of packets exchange on the network. But right now, yes, the thing is that, to be honest, my setup here is, I think I have something like 25 or 30 meters of cable. So it's not very long. It's far away from the maximum length that you can reach with a CAN for 125 kilobits per second. So yes, it's pretty sure that it's not only possible, but it's pretty sure that for some extreme cases, there may be some issues. The thing is that honestly, I just took a quick look in the timing configuration, because what you do, I can show you how it is done. I will.
Actually, we probably don't need to spend the time here with all the others listening. But if you send the timing parameters to the mailing list, we can compare it to the expectations, and we have a spreadsheet that we can punch in the timing parameters, and then we can figure out what kind of performance we can expect out of that.
Yep. Do you see my screen with a source code?
Yeah, I can see your screen. Yeah.
Yeah, this is the way it's configured. So this is the way you pass the parameter for the timing. So you have to give the core clock and the expected bit rates, and then it calls this. So you have to take a look. It's completely open source, so you can see how it's implemented in it. I remember that there is a table somewhere in the if you look at the GitHub where the source code is located.
So I prefer not to spend time reading this driver, but if you have read the driver and you can find it in like 10 minutes, then just post it to the mailing list and we'll review it.
Okay.
Just post the timing parameters to the mailing list and we'll just punch it into the spreadsheet that's on our GitHub.
I will take a look for that for them, and I will send them. No problem. So I continue on that. So what I've done is simply because I wanted to do something to start. So what I've done, I just I will not say reproduced. It's not the case, but I was inspired. That's more the idea. By the CanVout kit, which the original kit from the MERG is using a PIC microcontroller, and the idea was to use here a Pico using so the CAN 2040, and so basically I wanted to reproduce this. So it's basically an I/O module that you can configure. And what happens is, so that's the code I was showing you. That's the source code of the project. So I can show you. This is where the code is implemented, and so this is a schematic. So it's just a prototype for now. So you have 16 I/O lines that you can configure in many ways, and once you do that, that was my first achievement. I have been able to make a node which was recognized properly by JMRI. So JMRI itself here communicates using a CAN USB 4 kit. So it's I would say the interface that I use from JMRI is not something based on the Pico and based on the CAN 2040 library. It's a real CAN adapter based on the PIC microcontroller. But as you can see, they communicate perfectly. So what I've done, and I'm working on that right now, that's the library that I have written. I called it libopenLCB 2040. The idea is, so I will put it, I'm still doing tests on it, but I will put it on my GitHub. So the thing is quite simple. You have to define some configuration parameters in the source code, and then you have to. So that's the code I've written. You have to call this function, and when you do that, so once again, it's something that I started just a few months ago. So it's absolutely far from being perfect, but it's working. So this is the code running on the board, and when you run this code, the board that I've created appears like that in JMRI. So it's communicating quite well. So I once again, so what I've done, by the way, the last thing I wanted to say, right now, so I wrote libopenLCB 2040 for the Pico boards using the CAN 2040 library, and I am also writing, I would say, a generic version that I call libopenLCB, but for Linux, so for the Raspberry Pi. So it's basically using the same core, the same API. The thing is that it uses standard CAN interfaces, which can be connected to the Raspberry Pi. So if you have any other question.
So Benoit, David here.
Yep.
So you commented at the beginning about the documentation. How did you find the documentation from your point of view in writing code and trying to work for the specifications?
Alors, the thing is that I'm possibly not the best person to answer that, because I will explain you quickly. My job, my everyday job, I work for the French railways, and I read norms and specification. I will not say all day long, but not far away from that. So reading a specification is not something which I find difficult. I know how they are written. I know why they are written this way. So the only thing, honestly, that I found that was missing from my point of view was a kind of synthetic table, which lists in a very, very far away point of view all the possible messages. I found it.
Oh, you did find it.
I found a PDF, but it says that it's not up to date. But I found this PDF. I can show it to you.
It's called MTI allocations.
Yeah, something like that.
Yeah.
It is sort of up to date. It's not normative. Because
exactly.
Of course, it's not the standard. The standards are in the documents, and the table is just an extract that we made by hand.
Right.
So it's never going to be normative, but it is correct.
Yeah, you guys updated, I think, didn't you? I made the original one, and you guys put in the train stuff.
That's
probably.
Hold on, I will show it again. That's the document I was talking about.
That's it. Yeah.
Yeah.
Oh yeah. I do all of my coding with this sheet printed out in front of me.
It's
Me
very
too.
Yeah. Honestly, I found that this document is really the key to make the gateway between the specification, because what happens is that when you read the documentation, this is what you find. So you find MTI, which are you get these things, and at the moment you have to understand that you have to use this thing in CAN. And the way to honestly, that was the first difficulty that I found, was to understand how to translate this to this and why you have to do that. And this table was extremely useful to do that. But once you have understood the way the table is done and is built, finally, once you have done that, it's very easy to go back to the specification and read inside. Of course, the problem is for those who don't know, this is the loss. There are all the specification. So yeah, at the first site, it's really difficult to find everything, and especially the documentation is written both for CAN and for UDP transfer too. So you have IP, you have CAN, and at the beginning it's quite difficult to understand where you have to look to find explanation. But I would say it's once you pull on the wire, it comes quite easily at the end.
Did you find that the technical notes help, the TNs?
Yeah, they are useful because they are complements to the standard. Basically, I think you need both. I think that just using the S document, the specification, alone would not be enough.
Right. Yeah, the technical notes are supposed to explain why a decision was made and what the purpose is for, and so on.
Yeah, that's how I get them. Yeah.
Yeah. Whereas the standard's just the specifications, very dry and cut and dry.
Yeah, the thing that I'm keeping my eye on within MERG, obviously, we've now got a number of Pico board PCBs been made or are going in the kit locker, which are based around the Pi Pico. Ian Hart's designed those, which they're looking nice. I believe he's just done a version 3 of one, which gives you the choice between the MCP 2515 or the just having the transceiver. So these things are coming along. Obviously, when we started the group up, John Callingham was sort of doing the experimenting with the Pi Pico using David's library. As I know, Balazs had commented previously about the CAN libraries for the Pi Pico. Obviously, the OpenMMRN, who do the libraries for the commercial people, they haven't covered the Pico. I don't think Balazs must be busy at the moment, but the MMRN Lite, again, I don't know what that. I haven't seen any examples for the Pi Pico. Most of those are based around the ESP32. So it's one of them. From a MERG point of view, we've only got a couple of kits really that we could convert over to LCC. There's a lot of the MERG kits. What you call it? Duncan Greenwood's just come up with a board under a new Arduino processor that will mimic the CAN Mio device. One of the things with these ones, obviously, you've got the breakout, you've got the right components for your voltages and your current outputs. So, but whether they meet the standards that the commercial LCC stuff, I'm not sure. It's a bit hard.
Okay.
Balazs has just put something in the chat there. Sorry, Balazs, do you want to jump in, mate?
Just one thing, John.
Talk.
Oh, sorry.
Yeah, okay. Yeah, and I think that's right with balance support. It's very hard to try and support loads of different processors. I'm amazed how many David's sort of covered so far with what we've looked at. It becomes hard to keep up with it all.
I just wanted to show that on the board, this is the board which John was talking about. And if you look here, you have two jumpers on the board. They are located here. These two jumpers here allows you to connect directly the MCP 2562 to the Pico. So it's I don't know if it did it intentionally for the CAN 2040, but this is what you need to do with this board. If you want to use CAN 2040, then you don't install the chip here, the MCP 2515, and you just put the jumpers. So at this moment, the CAN transceiver is connected directly to the microcontroller on the Pico. That's what I wanted to show you.
I'm not sure if Nigel Phillips, have you had a play with any of the Picos? Obviously, these have been designed for CBUS, not LCC. I know, Nigel, you've been working on different boards of Ian's, haven't you?
Yes, I did the early design of that. We based it on an old one of mine, but that was based on a version of his. But now we got the Pico talking to CBUS using MicroPython. So there's a basic CBUS like Flim class written in MicroPython, and then from there you can add either the Wi-Fi connector or the CAN connector. And there's now a new Ethernet one as well for the WIZnet, because that board can use the WIZnet board.
Is that Duncan's library?
No,
A different one.
yes.
Okay.
This is a library specifically for CBUS.
Yeah,
So
but I thought Duncan had a MicroPython library for.
I believe it's one he uses, yeah, but it's fully featured, shall we say. Whereas the one I use is specifically for CBUS, so it's got a lot of the stuff cut out. It will still detect collisions and do CAN ID incrementation, but it's specifically designed to handle the grid connect packets coming out of CAN. But yeah, it's a work in progress. I've got the basic class working. I've got a few examples of nodes. I'm pretty sure this CBUS 2515 class will work with LCC. They're essentially both using Grid Connect. It's just that LCC CBUS is great. You just pass it through and then create a packet with just 8 bytes on it, or the full message, and then pass that out. And anything JMRI, MMC, they all pick it up quite happily. With LCC, you're going to have to do quite a lot of translation, unfortunately, and quite a bit of filtering.
Not really. I don't understand that comment.
Because your packet you're sending on the CAN, your messages, are very different to what goes out on an IP network. Whereas on CBUS, they're identical.
Right.
So you've got to put in the full address and things like that.
Well, you can send Grid Connect over IP if you want.
Well, I do all the time.
Then it's the same, right?
No,
You can send
because
LCC Grid Connect.
no, because a CBUS message is just 8 bytes, whereas an LCC message can be considerably more, which means
Sure.
it has to be split into different CAN packets. Yeah.
Right.
Also, on the CAN, it's using a CAN ID, which is a single byte. But when it goes out to the greater world, that gets converted into a 6-byte number.
Yeah, depending
So
on
your
what you're doing.
interface between and the has to do that sort of that translation, if you like.
Yeah, you don't need to do that. You can just send the CAN packets over IP. Tunneling, right?
I guess
You
you
don't
could
need
if you're going to another CAN network, but if you're going to a network server,
yeah,
I mean, this is
suddenly
this is
then
not the
if you
nicest
just do that,
solution.
you're limited to 255 nodes. Whereas the whole point of LCC is you've got a global address.
Yeah.
We have 4096. That's the maximum. So that's actually quite a bit. And we actually have like commercial products that you can purchase today that work with Wi-Fi and the OpenLCB over Wi-Fi. And this is exactly the mechanism that they are using. So they are basically tunneling the CAN frames over TCP/IP connections. That's how JMRI works as well. If you turn on the Wi-Fi, that's how the Wi-Fi boards that
so it's not converting the CAN frame to a proper LCC frame.
It is converting the LCC messages to CAN frames, and then those CAN frames are the ones that are being sent over the Wi-Fi. Yeah.
That does not seem.
I just thought, well, obviously we were going to be looking at showing what is commercially available, I think, and what do you call it? Alex Shepherd was going to give us a talk at some point. So this is the latest PDF flyer from Snowball Creek that I mentioned earlier. So these are some of the commercial offerings from Snowball Creek, and obviously I'm not really. There's not loads of information. I think this is what he's going to be talking about when he's at the convention. But this was the one that got me interested when I saw this one here. The fact that obviously he's using the I2C, the very cheap PCA 9685, which is one that I've used in the past for my layout when I originally set it up. using JMRI, and obviously now moving over to LCC. But these are some of the different projects that he's got on the go. And I say the fact that Bob, who's shown what he's been working on, there's a lot of people now seem to be working on different nodes that people can start looking at. A number of them are making the PCB designs available as well, which is good. Obviously, Bob Gamble's been doing some, so it's quite good. I know Balazs had made some of his boards available. Obviously, for us from him, we're sort of still new and scratching the surface of what we can actually achieve. And again, it would be interesting. I know Balazs mentioned that they've got a spreadsheet with the expectations you would get by the sound of it, with different things. So, the fact that they've got the commercial CAN, they've written their own libraries for the CAN. So it's looking promising for what's available. You've been also working on some new library as well, haven't you, David? Harris?
Sorry. Yes, I have. I've just been running it through the OLCB checker that checks it conforms to all the standards, so it's almost there.
So
I was trying to find Balazs's board that he made a long time ago. Here we go. Let's see if I can find it here. Yeah. Let me share my screen. Zoom, share. So can you see that?
Yep.
So Balazs made this a long time ago. It's a motherboard, and you see it's got a whole bunch of I/O on the outside, and it uses a Nucleo processor board that plugs into it, into these double rows here. The Nucleo boards are, I don't know, they're like $20 each or something. And
11
they have a lot of
or 12.
11? Are they still 12? Yeah.
I
So
don't think they
Balazs, you
raised the
could talk
prices.
about this, but it's basically we'll do anything you want. It's depending on what chips you put onto it. It's very flexible.
Yes, I mean the goal with this was to bring something that is easy to assemble for hobbyists, and then you can program it in the programming language of your choice through the Arduino environment, or directly if that's what you'd like to use. So the question was, how do you interface to your model railroad? And it has inputs and outputs in the various forms. I think there are 16 inputs that you can use either directly through screw terminals or using the wires like the railroad circuits. External input boards, like you can use the BOD8, for example, from railroad circuits to do block occupancy detection. But if you're just connecting push buttons or that sort of stuff, or toggle switches, you can wire them up directly. It can control, I think, 8 lines for motors. Like you have stall motors like tortoises, or you can have a little bit of a higher current like MP1s as well. That's the third port on the bottom left. And then there are 16 outputs on the bottom side, which you can configure either for driving LEDs to install resistors on the board, or you put in one of those Darlington transistor arrays if you want to drive higher currents, like LED strings or higher voltage things, or relays, or that sort of stuff. Finally, if you really feel like it, you can stuff stuff transistors directly, and then you can pull like 5 amps in every single port. But that's probably very fringe use case.
Balazs,
Yes.
are those connectors on the left? Are equivalent to the RR circuits?
Yeah, those are our circuits connectors.
Oh, great! So you can just plug in their peripherals in there.
Yeah, you can plug in their input boards on the left hand side. The block detector would be the one that you might be interested in plugging in there. There is no railroad circuits compatible for outputs because that doesn't really make a difference. Whatever output you want, you can do directly off of this board.
Right. So those ones on the left
how you populate.
Yeah, the ones on the left are only inputs, are they?
The top two on the left is that there are 24 pins on the left, right? The top 16 are inputs, and then the bottom 8 are the turnout drivers.
Right.
So those are for 4 tortoises.
Right. And that's what that chip
or 4 MP1s or something like that.
and that's
and then
a driver
the high
chip.
current outputs are on the bottom. Yeah, that's a driver chip for tortoise.
Yeah.
And then of course the Nucleo plugs in on the top. So this does not contain the microcontroller. In exchange, you can solder everything by hand. All of it is through hole. So it's pretty easy to put it together by yourself, get it as a kit. And of course, for your own needs, you might put a different number of inputs or outputs on it, depending on what you want on that particular place. The Nucleo comes on top, and that you purchase as one piece for like $12.
Yep. It plugs into these connectors here and here.
Yeah, exactly. And it contains all of the OpenLCB specific stuff on it, including power supply. So it can actually take power from the bus, and then you don't need to supply separate power at every single location.
And it can supply power too, eh? Take it or supply.
If you plug in a power supply to it, it will supply power to the bus as well. Yes.
Yeah, I've got one of these. I haven't stuffed it yet. I've got all the parts.
I mean, I have about a dozen. I stuff them in different ways.
Right.
Some of them with absolutely no input output. I just use it for running layout logic in there. So basically, getting all the events from the cable and then doing the logic computations and then sending back the resulting commands to the bus.
Guess we could.
I think the other
so it's open hardware. You can order the PCBs directly. There is a link that you can follow and then just order them directly, and they'll ship to you.
I think the other thing that was interesting. Sorry.
There you go. There's the board, and there's the Nucleo stuffed on top, and it has a debugger part on the top that you talk to the computer through.
Yeah, the other one that I know, David, you bought one of the STM32s for the CAN connection for the PC. But I must admit, I think you had a lot of work around because I think you use a Mac, don't you, to do your programming.
Right.
Obviously, that became another way of doing it, but it looked a little bit complex to me, so I never purchased one to try, to be honest. But I should imagine I think the plan was that can be done through the Arduino IDE.
This was a little board I developed that has the 2 RJ45s on it and a CAN transceiver and so on. So here's a TIVA development board that's plugged into it and then talking to the network. Again, if you wanted those, you could get them. It has a little power supply on it, but it's not very big, so not great. Okay, there we go.
So on this new library you're working on, David, is that a total rewrite of the OpenLCB single thread, or is it a separate library, or?
Yeah, it's basically a total rewrite.
All right.
I can probably go back, zoom. Let's see. Can you see that?
Yeah.
So there's this is your sketch.
Yeah.
Let's see. Ding, ding. So here's the new one. So what it does is it uses macros to define your CDI. So here's a CDI. It says a rep group. It's got a string. It's got an integer. It's got two events and another group. And then this generates the CDI and generates all the other stuff that we used to have to do, like over here. Remember, we had to make the mem struct, and we had to define the event table. Well, this does it all automatically for you. So this little sketch does two inputs and two outputs. And this is basically the entire sketch here. So it's a bit simpler, I think. I should say to people that we have a configuration file here that sort of sets up, you pick a board, you pick which board you want. So here we got Nano, ESP32 Atom, and Minima. And you kind of set up your stuff. And then the board file has the definitions of the different boards. So the ESP32 board has these I/O pins, and here's the connection to CAN, and this is the library for the CAN. And then if you go down here, like the Minima has a different library for CAN, different connections for CAN, and so on. So it's kind of nice. So you just go to config and choose which board you want to use, and then compile it, and it'll compile for that board. So it's pretty general.
Yeah.
The new version, the advantage is that it uses a storage class, which can be internal EEPROM, external EEPROM, external FRAM. You can just define those. It will do ranges for events. LCC has a thing called event ranges that will let you say have eight events in a row that you can send it as one event, and it's part of that range. And then you can, so it's great for, say, sending aspects from one board to another. And what else did I add in here? It's got some extensions which are nice. Oh, it does events with payload too, which is equivalent to events with data in CBUS terms. So, and then of course I have my to-do file here.
We keep adding different things in it as we go along.
Yes.
So, obviously, Bob, I think Bob Gamble, that you were looking at using different external FRAM chips, I think it was, wasn't it? It's one of the issues you were looking at.
Yes. So this,
He's waiting for this.
yeah, this would solve a number of the things that I was kind of waiting on with the existing single thread library. David and I had some challenges with getting external EEPROM to uniformly work. And so
Right.
I'm assuming this new one supports the Pico, right? Right, Dave?
Well, it will. I don't know if I don't think I put it in yet, but basically it's just
I didn't see it when you were scrolling through your boards there. You know, I did
No,
notice
but
the lack thereof. So,
well, it's just a matter of copying it over from the old one, right? Basically.
yeah, one would hope.
So what I've kind of done here is, like, if you look at the AVR file here, it contains the EEPROM stuff, and it'll contain the so here's this is internal, external EEPROM, external FRAM. So in the you can't see what I'm doing because Zoom keeps putting something up. So yeah, so in the config, you kind of pick your board, pick your storage. So you could pick internal, external, or external FRAM just by uncommenting the one you want, basically. And then I've again made the definitions for the different boards there. This is me playing around with this won't be there. It's just there because I've been playing around with different sketches. So
Because the nice thing is obviously that the two servo and 24 IO, if you've got an ESP32, you can very quickly change it if you've got a minima. So that's the nice part of it. Obviously, the way I was trying to show it was this is the code written for this particular MCU and this
right.
configuration. But you can use these as examples to learn how it's done, to modify them. For people who are better coders than me, that you can learn from how it's done to create your own type of things.
So there, I just compiled it on the Nano R4, which is like a minima, and then you could pick a different one. I don't know. I doubt it. It's probably not going to fit on a Nano anymore.
I think
Let's
we're
see.
already on the limit, weren't we? Last time, to be honest.
Where did I pick my board here? Can't find my. Oh, the other thing I did is this is your idea, Bob, I think, or someone's idea that instead of us having to say factory reset, it actually it looks at the CDI, and if the CDI is changed, then it'll do a complete reset.
Yeah.
So you don't have to
Cool.
keep doing this every time.
Yeah.
It'll do it automatically. So that's nice.
So is that we're not having to change the 1 and the 0, or?
Yeah, you don't need to. You can force it by putting this to a 1, but you don't need to. So if you make a change to your CDI, you add a integer into it or something, then I'll go, oh, it's changed. I need to reset all the events again.
All right, okay.
Yeah, so it does it automatically. Oh, here we go. So we set nano. And turn off this one. Let's see if it compiles. Yeah, it compiled. Use 66% of the program storage. So that's pretty good.
This has only got 2 input and 2 output, though, hasn't it?
Yeah.
Yeah, so it's quite a small compare. Plus, you haven't got all the different events that we had. But this is the thing where we're able to do the testing, being able to use the grid connect as well while we're doing testing, and then connect up the CAN bus and then start playing with them more. So, how's the progress going with the other one that you were working on, David, for all the peripherals?
This is the action sketch.
All right.
Config. Change it back. What did I do? Change it back to the minimum the R4 Nano. So this one's a bit bigger. Where is it? Oh, here we go. Action sketch. So oh, I know. I'll have to show you the CDI. So choose 4. I've got all different CDIs in here. Anyway, it's kind of complicated. The action sketch will let you define a whole bunch of actions. You get to choose which pin you're talking to and then what you want to do with the pin. And so, like he was saying, you can have an on action, an off action, a blink action, a strobe action, random action, etc.
Oh,
Yeah.
so when is this going to be available?
I would say in the next week or two.
Oh, cool. I look forward to playing with it.
I'll need to add in the Pico stuff and stuff. So
Yeah, that would be nice. That would be nice. So you
what do
do
you
have a
use?
board. You do have a board to test it on.
Yeah. Now tell me about your board.
So
I
you have it,
just
right?
yeah. And I just I just got I just found I got a printer for Christmas, a 3D printer. So I'm making myself a little turntable.
Oh, cool. Yeah.
And I know someone that had some turntable code, I think.
Yeah. Yeah. I'm working towards that. So,
So that's one of your boards, right?
well, it's I think the board that you have has a place there that you can put a stepper motor driver
Yeah.
on it,
Perfect.
and you can run your turntable off of that. So we can chat about that.
Yeah.
And yeah, all you need to do is solder the headers on there and plug the thing in. So it's one of those guys that you
Right.
plug in.
Which one do you recommend?
I can send you a link. I think it's a big tech tree or big tree or something
Oh,
like
okay.
that.
Because there's a bunch of different ones that are all pretty compatible, right?
Yeah, they're all pretty compatible, but there's one
Differences.
that I would recommend.
Oh, good. Okay. I'll
And
email you separately.
yeah, and so yeah, that looks really encouraging. And I've been playing with Jim Kueneman, who has the Open LCB C Lib that
Right.
that
C-Lib,
he's
yeah.
that he's been developing, and I sent him a board, and so he now supports the Pico in his code, which is still a library in development, but we have we've got it working using EEPROM as memory. It produces a CDI and communicates with JMRI, and uh, we're we're
Great.
we're we're now getting it to the point where it's going to start handling the events and all of that good stuff.
So,
And it does
yeah.
firmware updates.
Yeah.
Yeah, just throwing that in there. So yeah, it successfully
On the
executes
on the
firmware
Pico.
updates
On Pico?
on a Pico.
Oh, I haven't looked at firmware
Yes,
updates.
sir. Yeah.
I didn't approach that because it's almost impossible on AVRs. I mean
Well,
the ESP.
Jim said he did it in like a couple hours.
Oh, well, so there must be a library that supports it or something, I think.
The Earl Philhauer
Yeah.
board base supports little FS, and so with just a little code in there, Jim was able to pull in the bin file from JMRI, put it in the little FS, and do a reboot, and then it just
Right.
loads it in. So
Ah,
Bob's your uncle.
okay. That's good.
So yeah, that was really cool.
I wonder if we can generalize that, then we should better do it for the SP32 and the Pico. And you need enough memory, right? Because you need double the memory.
Well, yeah, that's not a real problem when you got 4 meg.
Right.
You just slice it in half, and you're still in Fat City as far as I'm concerned on memory.
That's right.
But yeah, no, it works beautifully. So he's
What are
been
you
keeping me busy while you've been rewriting your library.
so what are you using for CAN? Are you
So
using a external chip or are you using
oh yeah,
the CAN
yeah,
2040?
it's
Oh, the
the
2518?
2518 and the 2562.
Right.
Yeah. So yeah, I've got a design with that, and then I've got a design with the integrated one. But the separate chips are easier to solder, so I prefer that. So yeah, that's my my latest board, you know, for that. And so I've got the two chips on there.
Yeah.
Right down in there.
Oh, and you got this set up to drive smart LEDs?
Oh yeah, so this is my board that will drive 4 strings of nanopixels or neopixels, and the intent is to drive you know, all the lighting in my structures and cities and all of that sort of stuff. But you know, you could easily code it up to do other things if you wanted to drive a string of
Signals
or whatever. You know,
Yeah.
that would be easy. But yeah,
So are your designs available for everybody?
they could be. I've been hesitant to load them up on GitHub, just making sure that they're working and everything. But you know, I could throw them up there.
Yeah, I think we should probably make a catalog of what's available.
Yeah,
Because you know, getting boards made these days is pretty easy, right? So.
Oh yeah. You know, I can get 5 of these shipped to me for $12. So
That's incredible.
I think that's going to be a key, though, isn't it? Is we'll eventually start collaborating and catching all this information somewhere, whether it's on the.
Yeah, we're going to have to make a website or something for that.
Yeah. Obviously, for MERG members, I can put stuff on the MERG website, but for non-members, obviously that gets lost. So it's a bit of a pain doing it that way. But you know, it's one of them. The ones that I've seen already. There was another guy who put some files available for the ESP32 on Group IO. I can't remember who it was now, and I looked at them. That's when I realised. I think one of the problems we were having, David, was the fact that we were allowing people to choose whether they were inputs and outputs on the CDI, where if we'd have predefined them as inputs or outputs, we could have used more of them. So when I was trying to mix, there was some of the pins couldn't be outputs.
On the ESP32?
Yeah, it was a pain. But if you predefine them, so right, this is going to be 16 inputs, they could all be inputs, or this is going to be, obviously you might have to put a delay in it while it's compiling or first running up. But that was one of the things that was slowed me down when I was trying to do the testing of all the IO pins, because what would work on one thing, when we changed it, it suddenly affected another pin. So that was something that needed looking into with it. But again, I've used the ESP32s mainly for Wi-Fi for another project, and that worked beautiful. But I say for learning for the LCC, there's a lot of gotchas. It's catching me out a little bit because I haven't done that much with it.
Can I throw a few ideas in, John? Just float things, just to get, you know, see any reaction from anybody. Just to give a bit of background, we've got a new layout coming up at Lawlog, and it's at the stage now where the baseboards are up, the track is down, the points are, you know, having servos fitted, and I worry that you know, we wanted to use it as a test bed to learn a bit about LCC, and then hopefully to take it out on exhibition and show other people this is what LCC can do. I suspect that, you know, our chairman is going to pull the shutters down on that and say, no, we haven't got the time. It'll just have to be a, you know, traditional 1 wire per function installation, which would be a shame, but, you know, we'll see. But the thoughts that I'd had, and I know we've talked about this in the past, John, are that, you know, there are people like us on this call. There are some people who are really into coding, not as much into electronics. And there are people who are into the electronics, and not into the coding. I fall into that category. You know, I really need to get up and running with coding. Haven't got the time, but there we are. And then there's the other 99% of railway modelers who would rather run a marathon than do either of those things. And I think we probably all recognize that that's the case. So if we were going to get more uptake with layout control buses in general and LCC in particular, which I think has many advantages over a lot of the other buses, then it needs to be cheap. Sorry, good value sounds better. Good value. And it needs to be incredibly simple for them to set up and operate. And I know that's where both David and John have been working towards this sort of modular idea, and, you know, easy functions incorporating existing modules that you can buy at very low cost from the likes of AliExpress. And my thought was that if we can have a core processor unit like an ESP32 or whatever, surround it with the little cheap sub-modules that you can buy from AliExpress, like the MCP23017, like the PCA9685, my view would be that if people want to use the direct pins on, say, an ESP32, fine, that's great. My view is that I would rather, from our point of view, just use I2C off the ESP32 and feed the peripheral modules. And that way, everything appears to be modular, even down to the sort of the connectors, because you're just multiplying them. You know, they all look the same, they all have the same function. And David came up with the great idea that if we put the sub modules in that way instead of that way, then of course it reduces the footprint of the product. Because I was thinking we could have a little 3D printed frame, and all the little sub-modules clip into them. Then the wiring on the layout will come in sideways straight onto those sub-module boards, the peripheral boards. But the other advantage is that for anybody who has an accident with a screwdriver or a piece of wire or whatever, that way there's nothing going directly from the layout installation wiring onto the processor board, and therefore you've got a fair chance, not a guarantee, but a fair chance that the only thing that you will fry will be one of the peripheral boards. Now, if you're at an exhibition, you want to make your layout as bomb-proof as possible. Yes, mechanical mounting is an issue. Yeah. If you're at an exhibition, you want your layout to be as bomb-proof as possible, but also as quick to repair as possible. So if you can avoid having to replace the actual microcontroller, then it saves you having to even hook up a PC or something similar and hit the restore button. On the assumption that you're not running with a PC all the time, which a lot of layouts don't still. So to me, it seems that if we can make it totally modular, based on the little modules that you can buy from AliExpress that are fairly standard, PCA9685, MCP23017, maybe a transceiver, the Texas SN65 LVD 230, something like that as the transceiver, then that gives you a lot of advantages. The only one I think we'd have to actually build would be the twin RJ45 and power injector. But again, there's an advantage in having that off that module, because that way, if you do have to replace a complete module, and it would be sensible to carry complete modules as well as the sub-modules in stock at an exhibition, then you can unplug that module without unplugging the data cables. The rest of the layout keeps running, and hopefully the public don't even know you've got a problem, unless your feet stick out from under the baseboard and they can see them. So that was my sort of thinking about that. And by using something like an ESP32, which has got the CAN controller built in, you only need the transceiver, and you're handling all the CAN functions fully and correctly. There was a bit of a discussion going on the other week. I think it was after your talk, Benoit, about the CAN 2040, and I was looking at the business of the transmit error count and the receive error count, and it struck me that if you want something to be as bomb-proof as possible, CAN has been designed to be bomb-proof. If you're driving your car, you want it to be as reliable as possible, and it therefore sort of seems a shame not to incorporate every aspect that you can to make it as reliable as possible. And by using the CAN 2040, you're losing the ability to deal with the case of a babbling node, where a node completely goes mad and just starts flooding the bus, and you can't then disconnect it from the bus, or it won't disconnect itself from the bus. So my thought was, it's probably better to use a CAN controller that will handle that. And there's also this issue with the 2515 not having enough buffers, so that if your processor is a bit slow and not able to pull everything off, particularly with a storm like start of day where you've got lots and lots of messages, then that's perhaps not the greatest controller to use either, if you need to still use a controller. So those are my sort of thoughts on how we go about it to make it as cheap as possible, good value, and to make it as easy as possible, because we've got to show the other 99% of railway modelers that it's doable without a degree in computing and a degree in electronics, because most of them will just run a mile otherwise. So
yeah, I think that's where I came in originally, was from learning from Little Wicket Rob, showing how you do it with CMRI. So if we could do the modular approach, yeah. Obviously it's trying to come up with a scheme that would interest people, but also having people to do testing, because obviously I started off with the Arduino, understand the issues around that. Then went with the ESP32, especially because, as I said, with having Balazs come in the call a few months ago, and seeing what they've done with it and the reasons behind why they've gone with the ESP32. Obviously, there's the STM32s as well. I've not played with them. It would become another learning curve, which I haven't got the time to do. But I do like the Minima as well. But it's one of them. It's obviously mine is an Arduino layout. That's why I sort of kept playing with the Arduinos. But again, I think looking at the fact that a number of people are playing with the Pi Pico, good. I want to keep that. Then people keep doing it. Let's see how far they can push that controller, because obviously it's got a lot of people are interested with using it. Now, obviously, we know it's been a number of people have been testing it within MERG with CBUS, which again is still CAN based, and not seeing any issues with the buffering. But obviously, the people behind LCB have seen issues with buffering in the past. Now, whether that was library issue, I don't know. But using the ESP32, now I say I'm playing more with it. I know you're looking for the PCA 9685. I've got one there set up to have a play with. But again, I need for me to do the promotion of it outside of MERG in the outside world, I need to start showing it on a layout. It's one thing to show one or two of them on a demo plank, but you need to see it in the real world. Obviously, the idea within Merseyside was we were going to use one of the planks to push it further out, but that sort of stalled a bit. So that's why my layout now is being used to demonstrate just what we can do with the DIY stuff. I wasn't too keen with the PCA 9685 when I played with it, because the temptation was, well, I've got 16 servos and I run my wires all around the layout and it's in the loft. It was like, Yes, it was only the data. So all the data went out, the voltage went separately, and it worked. But I didn't want to get back into that situation. I wanted to start now local. Just because I've got all them pins, I don't want to, you don't have to use them. So like you said there, if people work, the likes of myself and probably David, we will use the pins on the native pins, but if people don't want to use them, that's their choice. So yes, this week I asked, can we have the second MCP? So that's what we're working on. Once we know that works, in theory, we could push that a bit more if we needed to. It's certainly going to get messy with the amount of wires. So the next thing will be, when David's got time, we'll have a look at adding the PCA 9685. So then you've got the MCP 2317 can give you the inputs. Then you've got your outputs. So you're not worried about your driving your voltages, are you? Which I know is one of the concerns. I have run 3 servos on the shields I use. The voltage regulator will supply 1 amp on the ESP32. So you start running into limits. So, it's one of them. These are the different things. Yeah, what you got up here, David? I think you're muted, David.
Do you realize you're sharing, David?
Couldn't figure out how to unmute myself when I'm sharing because I can't see the mute button.
Yeah, it hides it on you, doesn't it?
This is for David. This is the adding the PCA 9685. So this is it lets you have 2 23017s and 2 PCAs.
Cool.
And so so here's your part. So what I've put in is 2 positions. Is that all you want? 2 positions? Two positions.
We
and then
need to know the midpoint as well to be able to switch a corresponding output on one of the 23017s for changing the frog polarity through a relay.
Right. So this has two extra events, 1 cent when you're going one way and 1 cent when you're going the other way.
Yeah.
And it calculates the midpoint by the average of the 2 endpoints. Do you think we need a adjustable midpoint?
Well, as long as you know what the 2 endpoints are, I think that's probably near enough, isn't it? Because the midpoint is going to be the middle of those 2 somewhere.
Right.
I think we used the midpoint to help set the thing up to start with.
Yes.
So we normally go for a 90. So when you first set them up, you'd have your midpoint would be 90. So that's why we normally have 3 positions. But as long as it started at 90, then you would do your adjusting to get your 2 endpoints then, wouldn't you?
Yeah, this starts at 90.
Yeah.
The other we talked about. Sorry, I was going to say we talked about start of day a while back as well about being in the unknown position and so forth. And I wonder whether or not the simplest way to deal with that is just to set all the points to the midpoint, so that because there could be they'll move suddenly at switch on, won't they? But if we move them all to the midpoint, and they'll stay there until somebody actually sets a point in one direction or the other. I don't know whether that's something that's defined.
I don't think we have a problem with start of day, do we actually, David Harris?
Not really, no.
The nodes, they all tell each other what they're working with. So.
Right, okay.
Is that right, David, or am I got that wrong?
Well, I think we have a choice. We can, do you want to save the position it's in? I think it's safer to go to midpoint and then move to one or the other sides.
Yeah.
Why don't you just use the limit switches to figure out which direction it is pointing right now?
That assumes we've got limit switches.
Yes.
But you better have limit switches, otherwise you have dead frogs.
Well, not if we're switching the frog with a relay.
Well, remember
Yeah.
Who
that
switches the relay then?
Well,
remember that a
that's the point.
servo may not be attached to a turnout. It may be attached to a door on a structure or something like that, and you don't want it moved. You want it, to initialize in whatever state it physically is.
Mm.
Right.
Well, but then you need to read back that state,
Yeah.
or you unpower the servo and you don't power it until a command comes.
Yeah.
That also works.
I
On
know.
the 9862, if you set the pulse output to 0, then the servo is going to be not energized.
I was just about to say that, because I seem to remember there was a problem if you use the enable pin on things like the PCA 9685. It as soon as you re-enable it, it can twitch. Whereas if you set the actual data to 0, it amounts to the same thing, but it doesn't twitch. Is that right?
Yeah, actually what you do is you set the on to 0 and you set the off to whatever the top is, 496, I think, 4096. It's one past the end point.
Yeah. Well, it effectively gives you 0 volts or 5 volts, doesn't it? I suppose. Because
No, well, I think it just stops sending any pulses at that point.
Yeah. But the equivalent would be that.
Yeah.
Yeah. If you were using it for its original purpose of LEDs and whatnot.
So yeah. Anyway, we can take this offline for these discussions.
Yeah, absolutely.
Yeah, I just have 10 servos attached to doors on my roundhouse, so
Ah,
You don't want them all to suddenly go to half open.
because you never know. There might be a locomotive halfway in, halfway out.
Yeah.
that's right. Yeah. So what do you do, Bob? Or is that-
Well, right now it's running on a LocoNet node. That's what I'm trying to do is change that over to being a DCC or LTC node.
So I guess actually Balazs has got a good idea. You just don't send any pulses until you know where you're going to. That would make sense.
Yeah.
So you
Yeah,
just
I'm not
leave it-
sure how mine actually works. I just, plugged in the code and the library, and I haven't had that problem. So
Just thinking about it, the only thing to think about there is that if you don't know where it is, you don't know which polarity to set the frog, and you could end up shorting across the track. Although it wouldn't matter until a loco goes onto it, but the risk is that if the point is set the correct way, the way you want to go, and you haven't changed it since the start of day, you might run onto the frog and end up with a short. Because you don't know which way to set, you don't know which way the relay needs to be set to match whatever the point is in, what state it's in.
So I guess that's the advantage to having micro switches.
I suppose it is. I mean, the micro switches are always simpler from that point of view, but they do tend to be fiddly to set up and fiddly to
Keep set up.
Yeah, I mean, the arms sometimes bend, and again, in an exhibition situation, you want to be able to swap stuff really quickly and not have to faff about setting it up. Yeah. Something that needs thinking about, anyway. Another thing that needs thinking about in the enormous list of things.
Well, at least we've got some code there now for the PCA 9685. So that's something that.
So the advantage of this idea is that obviously the MCP 2317s could be inputs or outputs, but the PCA is always output, so it simplifies things a bit.
I mean, I don't want to throw another spanner in the works here, but I mean, at some stage, I don't think we'll actually need it for ours, but for large layouts with big control panels, you might want to think about having even just more than two 23017s. But presumably you wouldn't need any PCA 9685s, because I can't imagine why anybody would want one of those on a control panel. So maybe maybe an opportunity to just replicate the 23017s as many times as required would be useful, because then you can stick it
Right.
at the back of the panel and just wire all your switches and your buttons and so forth onto those. But I don't think we'll need that many switches for this new layout. It's not big. Although it's got one baseboard that I think has got 6 points on it, and that's despite the fact that the baseboard is only about 4 feet long, because it's got 2 double slips on the lower level and 2 points on the upper level. So in O gauge, that's quite a lot of points in a small area.
I think that's where it will come in, where we'll have a number of different example sketches, to be honest, because you could set something up, but then obviously what happens if it's looking for something in the sketch, if you told it, well, I'm going to have so many I2 devices of this type, and depend on how it's working. So there's a lot of things to look into there. I know with the MCPs at the moment, I think 2 will do me for what I want. I'll just put an extra node there.
Isn't there something that isn't there something that'll sniff out I2C addresses that are valid?
Yes.
Well,
You can scan.
Could that not be used just to scan to find out what's on the I2C bus, and then it goes, oh right, well I've got 2 23017s and a 9685, or I've got 3 23017s, or whatever. Just a thought. I mean, as I say, I don't think we need to worry about it for in the very short term, but I think the key to getting people to use a system like this is modularity. If you can make everything really simple using standardized modules that you can then just replicate, and they can just go, right, I want 1 of these and 2 of those, bang, done. That's what's going to get people in. If they have to think about it too hard and change this and change the code and do all that, they're going to go, ugh.
Well, that's where having the multiple examples I've got now, you choose the example to suit what it is you want. That then all they've got to do is change 2 lines of code. Now, if they're trying to change in 2 lines of code, the LCC is not for them.
Well, yes.
True. It's one of them. We can only do so much as volunteers.
Absolutely.
None of us, as Bob McCown said, he's not interested in being a commercial developer.
Yeah, absolutely. Totally.
And I'm the same. I'm happy to do certain things, and make the designs or the codes and put documentation as plain as English as I can, and make videos to show people, look, this is what we can do. But I'm sure if we could have an ESP32 on a carrier board that, as I think Bob was showing, or one of you guys was showing, he's put the MCP 23117 on it. Bob McCown was just showing it.
Yeah.
So we are a group within MERG who are happy soldering and PCB designs, but we've got to find people who are happy to do that type of thing.
But that brings us back to the issue of if we want to make LCC wider use, we've got to find a way of bringing in the people who aren't like us, and that means not having to send away printed circuit boards and solder up stuff, because people just most of them will run a mile rather than say, oh yeah, we'll have a go at that. We're different. We're the exceptions here. We're not normal in that respect.
All I know is from what I've been doing over the last year since I started, or year and a half since I started the journey, the amount of views and downloads of the software is quite amazing. How many people are actually downloading and playing with it or whatever, I don't know. The hardest part is getting feedback.
Yeah, yes.
So you just don't know. Not obviously, again, by reaching out through MMRN, there's MRH, sorry, and in the UK, RM Web. We're slowly getting it out there. Look, this is what we can do. Obviously, a lot of people now are looking at NowRail and the SP32 for Wi-Fi. And, Simon's doing a lot of work there. But for me, I don't want to use Wi-Fi, not on the layout. Obviously, I'm going to have too many nodes, I think, to do it. But I'd love to put one or two of these nodes on the layout to play with them, to see how well it does interact. But it would have to be something that isn't critical. Obviously, Bob was showing what he's doing for his garden layout. What's your layout, Bob Campbell? Is yours an external layout or small layout or largest layout?
Well, my layout is in my attic, which is 25 by 20 feet.
Yeah, about the same as mine then. Yep.
And 1.5 levels. So
Nice.
And that's the roundhouse that has that's automated with a turntable and all that good stuff.
So are you mixing CAN bus and Wi-Fi?
No, I believe in copper.
Right, okay, yours is all CAN.
There
Yes.
are times when a piece of wire is just what you need.
Yes. If my wife had let me put a garden layout in the backyard, then I'd be looking at Wi-Fi. But
Yeah. No, I say I know there's a lot of people within MERG who like to do exhibition layouts. So the CAN bus for exhibition layouts is definitely a winner.
Bomb-proof. It's got to be bomb-proof. That's what you need. Did you see that what I posted the other day? Where Little Wicket were on Pete Waterman's layout, and they had a complete network failure on the RF side.
Yeah.
A lot of people have been saying, "Oh, it's all right,"
You can push things so far, and I say I know, and I am putting warnings out on what I've been doing. This is the test now, is to see what we can do with the units I've got. I know the SP32 with that transceiver is going to be more reliable, and once I get the examples working the way I want them with the help of David, then that will be made available as well. Obviously, the GitHub, I really need to revisit the wiki on that, because that was sort of slowly documenting where I got up to with it. But to make it more successful, I'd needed to sort out the droppers and all the I'm up to 25 blocks now, and that's before I finish the top level, the fiddle yard up there. So I knew I had to sort that bit out because it was naff wide, and if I was ashamed to show it, to be honest, it was mad. So this will be coming a lot further in. I'm just having a little look up. Benoit's put some stuff there, yeah. Some expansions. But there's a lot we can do. It's for me, it's great to see what has been done. Because obviously when I came along and started looking at it, my first approach was whatever I used had to work with JMRI, because I knew I needed it. So being able to use CAN was one option, but it needed to be able to talk to JMRI, and that's why I looked at CBUS. And then when I found LCC, David's library, and finding it in the Arduino IDE, it seems to be a great way to go. And now meeting more people who, really have got the knowledge and sharing it with people, which is good. So I'm just looking at the time there now. So I'm not sure, does anybody anything else? I'd say the next meeting I'm hoping to have Rick from what you call it. I forget the Richmond terminal to give us a talk as well. Hopefully we'll have Andrew Crossland be able to join us at some point with the work that he's been experimenting with. I think it's a Railcom booster or something, but LCC.
Yeah, booster with Railcom, yeah.
Yeah, because obviously that seems to be a big talking point now within the MERG group, a lot of people, I think there's going to be a small transceiver module being made available soon, or the PCB will be made available. I think that's Mike Smith's been working on that. I think obviously we'll have to get an update of what is actually commercially available as well, because the idea behind this group is we look at all of it from a fresh perspective from people within MERG who haven't heard of what LC is offering. So
On that aspect, Balazs, can you speak to the Railcom detector that TCS is bringing out?
Yeah, I suppose I can. Let me find one.
So they're coming out with an 8-channel Railcom detector.
Yes, I'm just having difficulty seeing one here that is not actually wired up. Maybe I'll show you in a bit later. Yeah, so we're making an 8-channel block occupancy detector where each of the blocks have a Railcom detector, and each of the blocks has a short detection circuitry. So that means that whenever there is a short circuit in one of your blocks, then it is only that particular block that gets shut down and not your entire layout. So this basically incorporates functionality of circuit breakers like PSX or PSXX, if you know that, directly into the block occupancy detector. So obviously that allows more flexibility for your layout. You also get to know exactly where the short occurred, because you get actually an LCC message, an event with the exact place where the short came from. So you can make use of that information as well in your control panel or something like that. What else is interesting to know? I mean, Railcom features. So you have the ability to determine what kind of locomotive is on the track and which orientation, like west or east, which can be helpful if you're trying to do train automation or maybe stopping trains at signals. That sort of stuff is pretty helpful. So you can set the signal to red, and then basically whichever the block that is just before the signal, whenever that gets occupied, you can basically set the speed to 0 on whichever locomotive is approaching the red signal. That's also kind of like an interesting feature of that. What else is interesting? This is a product, so you will be able to purchase that. It is going to be on display at the Amherst train show at the end of the week. So we're traveling like in a day or two. There's going to be clinics about it, and I'm hoping that Ken Cameron will also mention it during his clinics at the weekend. Awesome. If you have any questions.
Do you know how much it'll cost, Balazs, or is that not decided?
MSRP is $140. So it is roughly in line with equivalent devices for Loconet. And if you count the per channel cost of block detectors for just like regular stuff like railroad circuits, etc., that's also roughly a similar cost. Like $20 per channel is usually what you end up with. If you don't DIY the whole thing, of course. Right. DIY is always cheaper, but that's just not a product. And if you are trying to price it against like PSX, I think like a single PSX costs, I don't know, like $60 or something. You get 8 of them here.
Yeah.
So that is pretty good value.
So are any of the other vendors bringing new stuff out, Balazs, that you're aware of?
I mean, there were threads about this in the mailing list in the past couple of days. I just haven't been super up to date with them. Andrew Crossland is also working on a Realcom detector that's going to be 4 channels, but it's not going to have the short circuit capability. I think Andrew also is working on a booster that connects via the LCC cable. Then you've showed the Spring whatever Creek show products. That's what I've heard about, and then the rest that I've heard were DIY category products. TCS is bringing the Wi-Fi decoder as well, but I don't know what time frame that is going to be available for sale at the moment.
What scale is that for? HO?
Both large scale and HO.
And I think there was what's it called? Turnout Pro? What did he call it?
There is a
Bob
turnout
Jacobs.
boss,
Turnout
boss
boss.
from Jim Kueneman. I mean, I've gotten some of the prototypes for the turnout boss. The turnout boss is a product which performs everything that is necessary in and around half siding. So it has control for a turnout. It has 4 signal heads, multicolor, 3 or 4 color signal heads, and 3 block occupancy detectors, including the coils, CT coils. And it is LCC connected, and it performs all the logic necessary for this as well.
And
So
it's
you have
easy
the
to
ability
connect.
to connect two of the turnout bosses, and you don't even need to configure it technically, because there is a fixed assignment of how you wire up the signal heads. You can basically take them out of the package, and then with the teach learn a couple of button presses, you can pair them up in a specific way, and then they're actually going to send all the track reports between each other as well. So you technically have the ability to build layouts. Also, modular layouts work pretty well in this form, because modular layouts have typically more fixed track geometries. Because the big deal here is that you actually get the logic built into the software code. So you don't have to configure run JMRI for the logic, and you don't have to like go through infinite configuration panels to punch in your and or not and event IDs. That's a turnout boss, but I don't know what the turnout boss has this story about production, because if I understand correctly, it ended up being like super expensive. So producing it commercially is like not viable. It's sure a very nice design. It's also huge. Like the turnout boss is about like this big.
Oh.
Because
Yeah.
about this big and about this tall. Which is not surprising because it has a lot of hardware on it, with all the signal drivers and all the block occupancy detectors and then the turnout drivers, and I think it even has a servo output or something like that, or maybe 2. So a little bit of a lot of features.
I think that's the thing, you get some fancy equipment, but then it gets expensive because you've got all the specialist stuff into it. And it serves a purpose. With the DIY side, you're building what you want, but then it doesn't necessarily appear for what other people want. One of the things I was going to ask David or Balazs is, obviously, within our code that we're using, it gets an alias, doesn't it? But will it always get the same alias? No.
No.
Because what I was thinking of in my head is, if we know what the message on the bus is coming from a node, in theory, we could then put our own functionality or logic within that node. If you know it's always going to be the same CAN frame.
Well,
Not the same CAN frame. No, the alias is always different, but usually you don't care about the alias, you care about the event ID, and the event ID is the same.
So
The event ID is specific to whatever the event means. But of course, if you have different instances of the same situation, you need now different event IDs for that.
Yeah, so we can use the event ID then. That's okay then.
Yeah,
that's
yeah.
all that
Yeah.
was in my brain. The next sort of what I can do.
But the aliases, you can really forget about them, because every single code base that we are talking about here, like David's library or Benoit's library or OpenMRN or OpenLCB CLib or libopenLCB, all of these they handle the aliases for you. So all of these libraries have to have their own software solution for how do they translate the alias to whatever is relevant. So you really have to deal with, if you write logic, you have to deal with writing logic using however the library is set out to do that.
Yeah.
I think I promised you to show an example of this with OpenMRN Lite, and I guess I never delivered on that promise. I guess maybe 2 months from now I could have a presentation.
Yeah,
when things blow over a little bit here.
Yeah, because I remember you were using a lot of hard code in that. That's what I was like. Okay, that's it. Just bear with me a sec, Balazs, and I'll try and spotlight you.
Yeah, so this is the Realcomm detector board. So obviously it has LCC, the usual two plugs. You can power it with 12 volts. It is going to power to the bus, or you can get power input from the bus if you don't want to attach the power supply. This is where the DCC comes from the booster. There are two sockets for track A, 2 sockets for track B. So if you want to daisy chain them, you can daisy chain them. And then these are the outputs. There are eight outputs, and I have the counter polarity. So eight channels for track A, and the 2 outside are for track B. And for each of the outputs, there is a color LED here. So that color LED is going to tell you what the status of that output is. Like, is it running? Is it shorted? Is it occupied? And if there is a Realcomm enabled locomotive in there, then that's going to show that as well. That's it roughly. There are a couple of expansion ports that are currently not all in use. So there might be future software updates to enable them. On one of the expansion ports, we have the ability to connect little displays that show you the Realcomm locomotive in a particular block by the DCC address, basically.
Nice.
Yeah.
Yeah, they're going to be popular, Balazs.
I hope so.
I could see David Sands buying 40 of them or something.
You say who?
David Sander, one of the people that have big layouts, museum layouts and things. I'm sure would love that.
Yeah, maybe. Yes, I suppose.
I think it's people finding out what is available in it, and as we find more and more, and obviously from a UK point of view, we're normally only building smallish layouts, but yeah, some of the exhibition layouts are getting quite big, I think, aren't they, David? We've got a number of people, but again, normally I think it comes down to the cost, where some people sort of, if you're building a big layout, you've got to be prepared to spend some money out, haven't you?
Yeah,
Well,
I don't think that this is like targeted for big layouts, because realistically, even a small layout, when you have like more than one operator, having short circuit protection is actually like pretty helpful. So even in a shelf layout, or like a tabletop or like a 2 module layout, it makes sense to put this in. I actually designed this for my own layout. I started building my layout. And I basically put this board in every single section of my layout. I'm building something akin to a modular layout, but it's basically sections. So this board is handling the needs of each of my individual sections. And of course, every section has tracks. So I always start with with the one board that actually manages the track power.
Be really nice for people that have operating sessions on their layouts, because like when the guys come to mine and operate, they're always driving into a turnout the wrong way and shorting out and that sort of thing. And it'd be wonderful if they just had the problem, because they're all looking at each other, hey, who did that?
Yeah.
Yeah, I'm thinking of putting like lights in front of the on the fascia, like to drill a hole and put an LED through the fascia. So if you are the one, if there is a short on that particular section, then that would start like blinking or flashing or bright.
Well, you should be able to override the signal that's at that turnout and start flashing it. Give them the idiot flash.
That's an idea.
I like that. Yes.
Well, it sends an event out, so you could certainly do that.
Yeah.
Now it's good to see the products coming along. I'm not sure TCS at the moment in the UK. I think we've only got one supplier, and he's only got certain items. I think I've managed to see. Is it the TCS 50? Is it or something, that the little handheld unit that has got LCC outputs on it? That's the only one I've seen up to now available.
The LT50, I think
That'll
you
be
mean.
the one. Yeah.
Yeah.
I mean, I know that TCS has a dealer in the UK. I would expect that they have the full lineup. I'm not certain of the details. And then this might also be available there as well. I mean, it's a whole international shipping and tariffs and whatever question is really what it depends on.
Right, so we need to find out who the dealer is, and because I know Andrew did mention he was trying to get hold of one of the products, and he couldn't find it in the UK, so that might be worthwhile looking into.
Yeah, I think he wanted one of the CS 105s. The command station.
So the CS 105, I believe, is not certified. It's not certified to be sold in Europe. So that's not going to be
I see.
in the inventory.
That'll explain why then, if it's not been cleared for us.
Depends whether or not it's classed as a finished product or a subsystem. If it's a subsystem, it doesn't actually have to be UKCA branded, as it were, like CE branding, because that would then require testing if it was going into a commercial system that was placed on the market. But if it is a finished product on its own and stands alone, then yeah, it would need certifying.
All right. The other thing, I'm obviously on my lay, I'm using DCCEX, and I believe they've got something partly into the code now for LCC, but not sure what that is going to offer us yet. I think it's more. I think Alex said it was more to do with the traction side of it.
That would make sense. Yeah.
Balazs, did you guys wrote
EX, DCCEX and LCC, we have had discussions with them quite a bit over the last couple of years. What they were planning to do is to have a daughter board which connects to LCC, and the daughter board would communicate somehow with the original main board. And this LCC part would basically run their scripting language. So you can write some sort of macros or scripts or whatever for your DCCEX command station, and then the LCC would be somehow integrated into that scripting language. So it would be event protocol, but I don't know the exact details, and I also don't know how far along they are. I haven't heard of them in the last year at least.
I thought you guys wrote a little adapter for them. There's some code there.
I don't remember who wrote that.
I think it was Alex Shepard wrote it. Alex said he'd
Maybe.
done something on it. Obviously, the guy behind X-Rail is a MERG member, but I know I don't know how far he's planning to take it, to be honest. But for me, I certainly didn't want to use the I²C side of it. It would be, my layout's too big for that. But if we could talk to the LCC as well, then maybe that will be something in the future. But
I'll talk to Alex about it. There's also Duncan and I were talking to them about one for talking to MERG, so to CBUS. So
yeah, Chris has already been playing with something on that, but they didn't seem to want it. Duncan and them didn't seem to want to play nicely. So
well, we've restarted the effort, so we'll see what happens.
yeah, it's one of them. But for me, DCCX is only supplying the traction. JMRI does the link between the traction and the LCC for me now. So
Yeah.
that'll do what it's doing what I want at the moment. It's just we see where we take things, and it's nice being able to develop more stuff and look at different things that I am going to be able to do in the future with the SP32s. But so we'll see where we go. So right, I'm just getting to the point where I don't know if anybody's got anything else before we wrap up the meeting.